Ever wondered what could end life on Earth, or even the entire universe? In this calming yet mind-bending video, we'll explore 15 terrifying space facts that could one day change everything. From rogue black holes to the ultimate fate of the cosmos, these cosmic threats are real, but we'll guide you through them in the most soothing way possible. Sit back, relax, and let the mysteries of the universe gently lull you to sleep. 1. Asteroid or comet impact. Close your eyes and imagine the peaceful hum of Earth, the rhythmic turning of seasons, the dance of ocean tides, the quiet rustle of forests under a summer breeze. Now imagine, far beyond this serenity, a dark and silent traveler, a celestial visitor we didn't invite. An asteroid, a massive 10-kilometer wide chunk of rock and metal, silently coasting through the cold void of space. Most asteroids pose no threat. They orbit the Sun harmlessly in the asteroid belt between Mars and Jupiter. But every so often, one is nudged by a gravitational tug, a gentle ripple from Jupiter, or a long-forgotten collision, and its new path crosses ours. And when it's large enough and fast enough and aimed just right, it can change everything. One such impact happened 66 million years ago. A 10-kilometer asteroid struck what is now the Yucatan Peninsula. The Chicxulub impact, as we call it, released energy equivalent to more than 1 billion Hiroshima bombs. In seconds, firestorms ignited across continents. Forests and plains became oceans of flame. The sky darkened as molten rock and vaporized Earth launched high into the atmosphere, forming a thick, light-blocking cloud of ash and sulfur. The sun vanished behind that curtain. Without sunlight, photosynthesis stopped. Temperatures plummeted. Rain turned acidic. Plants withered. Food chains collapsed. The dinosaurs, those mighty rulers of Earth, vanished in the aftermath. Alongside them, nearly 75% of all species disappeared. It was one of the greatest extinction events in our planet's history. A silence that echoed across eons. And it could happen again. NASA and international observatories scan the skies every night. We track thousands of near-Earth objects, or NEOs, and calculate their trajectories decades into the future. So far, none pose an imminent threat, but new objects are discovered all the time. Some are dark and small, virtually invisible until they're already close. Comets, with their icy cores and elongated orbits, can appear with little warning, like ghosts emerging from the deep black. If one ever headed our way, the outcome would depend on its size, speed, and angle. A small asteroid might explode in the atmosphere, like the one over Chelyabinsk, Russia in 2013, blazing across the sky before detonating with the force of 30 Hiroshima bombs. It injured over 1,000 people, mainly from shattered glass. But it could have been far worse had it struck just a few seconds later. Larger impacts, especially over land or populated regions, could be catastrophic, and in the open ocean, even worse. Tsunamis racing across continents, flooding coastlines, disrupting life on a global scale. In theory, we might be able to stop it. Space agencies are testing deflection techniques, like kinetic impactors, hitting the asteroid with a spacecraft to nudge it off course. The DART mission in 2022 showed promise, demonstrating we can alter an asteroid's motion ever so slightly. Other ideas include gravity tractors, nuclear nudges, or solar sails. But for a truly massive object, or one discovered too late, our options dwindle. The comfort, if there is one, lies in probability. Impacts like Chicxulub happen only once every 100 million years or so. The Earth is vast and space is even more so, but the threat is real. It lurks in the silent corridors of space, watching, waiting, patient as time itself. And so we scan the skies quietly every night. A billion-year-old dance continues, and we are but brief partners in its rhythm. Sleep soundly tonight, knowing that though space holds dangers, it also offers time. And in that time, we prepare. Second, gamma-ray bursts. Now, drift deeper into the stars. Leave behind the gentle blue of our skies and journey toward the vast reaches of the galaxy. There, among dying stars and violet births, lies one of the most powerful forces we know. It is invisible, instantaneous, unforgiving, a gamma-ray burst. Gamma-ray bursts, or GRBs, are the universe's most energetic explosions. They occur when a massive star, many times the size of our sun, collapses at the end of its life. Its core implodes into a black hole or a highly magnetized neutron star, and in that moment, beams of gamma radiation shoot out from its poles. Jets so intense they can outshine entire galaxies for brief moments in time. These jets last just seconds or minutes, but in those fleeting moments, they release more energy than our sun will emit in its entire 10 billion year lifetime. If one were aimed directly at Earth, even from thousands of light years away, the consequences could be catastrophic. Our planet would be bathed in high-energy radiation. The ozone layer, our fragile shield against ultraviolet light, would be stripped away almost immediately. With the ozone gone, the sun's UV rays would pour in unhindered. Skin cancer rates would skyrocket. Plant life, unable to shield itself, would begin to fail. The base of the food chain would crack. Ocean plankton would perish under the UV onslaught. The cascading effect would be swift and merciless, toppling ecosystems one layer at a time. Gamma-ray bursts can come from several scenarios. Long-duration GRBs usually result from the collapse of massive stars and supernovae, typically in distant, low-metallicity galaxies. Short-duration GRBs, lasting less than 2 seconds, come from the merger of neutron stars. Collisions so intense they warp space-time and generate gravitational waves. Thankfully, the Milky Way appears relatively calm. No massive star currently close enough and oriented the right way poses a GRB risk. Stars like WR104 have raised eyebrows in the past, but modeling suggests even they are unlikely to be pointed precisely at us. Still, we remain vigilant. Telescopes like NASA's Swift and Fermi satellites watch for gamma flashes. When one is detected, data is instantly shared around the globe. Astronomers race to observe the afterglow, to understand the origins, and to refine our cosmic maps. The danger lies in their suddenness. GRBs travel at the speed of light. There would be no warning, no signal outrunning them, just an instant change, a shift in the cosmic wind, a new sky. But even in that, there's comfort. Their rarity is a kind of grace. The odds of one hitting Earth are vanishingly small. And the universe, while vast and violent, is also protective in its own way. We are tucked into a quiet corner of the galaxy, shielded by chance and by distance. So rest easy. The gamma-ray bursts rage on in faraway galaxies, too far to reach us, too fast to fear. They remind us of the raw power hidden in the stars, and the precious, fragile beauty of our pale blue home. And in their fleeting flash, they whisper of both the violence and the wonder of a universe still unfolding. 3. Supernova explosion nearby. Imagine, if you will, the quiet radiance of a nearby star. For millions of years, it has been a steadfast light in our night sky, slowly fusing hydrogen into helium in its core. But everything, even stars, has a life cycle, and for some massive stars, that life ends in one of the most cataclysmic ways imaginable, a supernova. Now, not every supernova is a threat to Earth. Most of them are incredibly distant, their brilliance dazzling to our telescopes, but ultimately harmless. However, if a supernova were to occur within roughly 30 light-years of Earth, we could face a cosmic hazard that's both awe-inspiring and terrifying. The core collapse of a massive star triggers a titanic release of energy, so powerful that, for a short time, it may outshine the entire galaxy. This energy comes in many forms: visible light, X-rays, gamma rays, and high-speed particles. If Earth were too close, this radiation could have dire effects on our atmosphere. The upper layers, particularly the ozone layer, could be stripped away or degraded, leaving our planet exposed to solar ultraviolet radiation. That's the same radiation that causes sunburns and damages DNA. But without the protective shield of the ozone, it would reach the surface in levels far beyond anything we've evolved to handle. This would not be an instant, explosive demise, but a slower ecological unraveling. Over months and years, increased UV exposure could cause widespread mutations in plant and animal life, disrupting food chains and collapsing delicate ecosystems. The effects might echo through generations, not just for humans, but for nearly every form of life dependent on sunlight and a stable atmosphere. One of the most discussed nearby supernova candidates is the red supergiant Betelgeuse, the bright, reddish star in the constellation Orion. Scientists know it's nearing the end of its life. One day, it will explode. But luckily for us, Betelgeuse is over 600 light-years away, well outside the danger zone. So why do we even consider this a threat? Because the universe is vast, and there are other stars within 30 light-years of Earth. Many of them are not massive enough to become supernovae, but if even one undetected, dying star lurked nearby, it could pose a threat without us realizing it until it's too late. However, supernovae don't happen quietly. As a massive star begins its final death spiral, astronomers can detect telltale signs: a dimming or flickering brightness, changes in its spectra, or even neutrino bursts. Nearly massless particles that can escape a collapsing star before light can. These signals would give us days, maybe weeks of warning. Not enough to escape, but enough to observe, to understand. And while that may sound grim, it's also a testament to how connected we are to the cosmos. These stellar explosions don't just destroy, they also create. Supernovae forge the heavy elements that make up planets, oceans, and even our own bodies. Iron in your blood, calcium in your bones, these atoms were born in the heart of dying stars. So while a nearby supernova would be an existential threat, it also reminds us that life itself is a cosmic inheritance. The stars giveth, and one day they may take away. But for now, Betelgeuse continues to glow peacefully and the heavens remain quiet. You're safe, you're small beneath the stars, but you're not alone. Let that thought guide you gently toward rest. 4. Rogue black hole encounter. Now close your eyes and drift just a little further from home into the darker corners of our galaxy, where light itself can vanish. Here lies one of the most mysterious and silent threats in the cosmos: a rogue black hole. Black holes are born when massive stars collapse at the end of their lives. In that collapse, gravity becomes so strong that nothing, not even light, can escape. Most black holes sit quietly at the center of galaxies or remain in binary systems bound to their star companions. But some are not so anchored. Some drift alone through space. These are rogue black holes, completely invisible unless they pass in front of a star or distort space-time itself. A rogue black hole passing through our solar system wouldn't announce itself with flashes or explosions. There would be no brilliant light in the sky, no radiation burst, just silence. Invisible, it would approach slowly, warping space and subtly tugging at the orbits of planets, long before we knew it was even there. If such a black hole came close enough to Earth, the consequences would be profound. Its immense gravitational pull could destabilize the delicate balance of our orbit around the Sun. Our seasons could shift unpredictably, tides would grow chaotic, climate systems could unravel as the Earth tilted or moved into a more eccentric orbit. In a worst-case scenario, the black hole could pass close enough to hurl Earth entirely out of the solar system, sending our planet drifting into the cold void of interstellar space. Without the sun's warmth, Earth would freeze over in weeks, our oceans locking into global ice, and nearly all life would perish in darkness. And if it passed even closer, it could tear our planet apart entirely. The gravitational tidal forces would stretch and compress Earth, heating its core, rupturing its crust, triggering earthquakes and volcanic eruptions on a planetary scale. Eventually, the Earth could be shredded into debris and devoured. But there's another eerie possibility. that a rogue black hole could have already passed nearby, tugging slightly at the orbits of distant objects, changing the motion of comets in the Oort cloud, or disrupting ancient celestial alignments. Astronomers are already watching for unusual patterns in distant starlight, gravitational lensing, or unexplained wobbles in planetary orbits. These may be our only clues, and yet, despite their danger, rogue black holes are rare. The galaxy is vast, and even with hundreds of millions of black holes, space is mostly empty. The odds of a direct encounter in our cosmic neighborhood are low. Not zero, but low. Still, it's the quiet nature of the threat that makes it haunting. No light, no sound, no warning, just a deep ripple in the invisible fabric of space-time, slowly creeping closer. Tonight, though, you can rest easy. The stars are calm, the planets move smoothly in their orbits, and the sky holds no sign of distortion. So breathe in gently. The cosmos is vast, but your place in it is real, grounded, for now, safe. Sleep beneath a sky held in balance by gravity and time. You are part of that harmony. 5. Solar Superflare. Imagine for a moment the gentle sunrise. Its warmth caresses your skin, and its soft golden glow marks the beginning of another peaceful day on Earth. Our sun, a star so constant we build our lives around it, feels like the epitome of stability. It rises and sets day after day without fail, but beneath its serene surface lies a turbulent, boiling sea of plasma, storms so vast they could swallow worlds. And sometimes, just sometimes, it erupts with a power that defies comprehension. These eruptions are known as solar flares, brief, intense releases of electromagnetic radiation caused by the snapping and reconnection of magnetic fields on the sun's surface. Usually, they're harmless to us. The Earth's magnetic field and atmosphere shield us from most of the effects. But occasionally, the sun produces a more powerful outburst, a superflare. And though we've never experienced one of these titanic events in recorded human history, evidence from other stars tells us that they are not only possible, they might be inevitable. A solar superflare would release energy thousands of times greater than even the most powerful solar storms we've observed. If one were directed at Earth, it wouldn't shatter buildings or flatten forests. Its destruction would be invisible, but no less devastating. It would begin with a sudden, blinding pulse of radiation hitting the planet. This would disrupt satellites, fry electronics in orbit, and blind radio communication. Then, minutes to hours later, a massive wave of charged particles, what scientists call a coronal mass ejection, would slam into the Earth's magnetic field, compressing it violently and inducing electrical currents across the surface. Transformers would blow, power grids would short out, GPS systems would fail. The internet, telecommunication networks, air traffic control, all could collapse in a matter of hours. In a world so deeply dependent on technology, the ripple effects would be immense. Water supplies, fuel logistics, food distribution, every thread of modern civilization would feel the strain. We've seen a glimpse of this before. In 1859, the Carrington event, the most powerful geomagnetic storm on record, caused telegraph systems to spark and fail, even setting fire to telegraph stations. But Earth in 1859 was not Earth today. Back then, we had no satellites, no internet, no global economy spinning on the axis of electricity. A similar event today would cost trillions. A superflare, far more powerful than Carrington, could plunge entire continents into darkness for weeks, months, or even longer. Some might imagine this as the end of the world, but in truth, it would be more like a forced pause, a stillness. Planes grounded, cities hushed, screens dark. It wouldn't be the end of life, but the end of our current way of living, at least temporarily. Scientists have detected superflares on stars similar to our sun. These bursts of energy, observed through telescopes and spectrometry, show just how volatile even quiet stars can be. The good news is, such superflares are rare. But rare in cosmic terms doesn't mean impossible. It just means they're separated by long, though quiet centuries, perhaps millennia. So what do we do with this knowledge? For many, it's a call to preparation. Hardening our satellites, building shielded power grids, creating protocols for rapid response. For others, it's a humbling reminder that our technological age floats on a sea of solar fire, brilliant, ancient, and unpredictable. But tonight, you're safe. The sun has set. Its warmth lingers on rooftops and in the air. Somewhere, far above, auroras shimmer gently at the poles, a quiet reminder of our connection to the cosmos. Let your mind drift, let the calm return. The stars are watching, and the sun sleeps for now. 6. Collision with a rogue planet. In the vast black sea of space, between stars and galaxies, lie wanderers. These are planets without homes, cast away from their solar systems by violent gravitational dances in their early history. We call them rogue planets, and they drift silently through the cosmos. Alone, dark, invisible to all but the most sensitive instruments. And though it might seem like science fiction, the existence of rogue planets is a scientific certainty. Some estimates suggest that for every star in our galaxy, there could be up to 2 rogue planets. That's billions of lost worlds, adrift in the cold. Most will never come close to another star system. But in the cosmic lottery of orbits and trajectories, most is not all. What if one of these rogue worlds wandered into our solar system? The approach would be slow, measured in centuries. At first, distant gravitational tugs on the outermost comets might go unnoticed. But over time, astronomers would detect small but growing irregularities in the orbits of planets. Neptune, then Uranus, then Saturn. Telescopes would find a faint shadow in the infrared spectrum, colder than any known planet, moving in a way that no known object should. A rogue planet. Depending on its size, speed, and path, the consequences could range from mild to apocalyptic. Even a distant pass could destabilize orbits. The Earth could become more eccentric in its yearly journey around the sun, meaning hotter summers, colder winters, and a chaotic climate. Ocean tides would grow stronger, perhaps flooding coastlines cyclically. If the planet passed closer still, it could throw Earth entirely out of the habitable zone, freezing or boiling the surface in time. And if in the worst scenario, it were on a collision course, well, the outcome would be certain. 2 planets, masses of rock and metal traveling at tens of thousands of kilometers per hour, would meet in a cataclysm of unimaginable force. The energy released would dwarf the asteroid impact that ended the age of dinosaurs. The Earth's crust would melt, oceans would vaporize, the atmosphere would ignite. Life, as we know it, would be obliterated. But here's the thing, these events, while plausible, are incredibly rare. The odds of a rogue planet entering our solar system and directly threatening Earth are minuscule. So why speak of it at all? Because the universe is not just stars and light, it's filled with mysteries, hidden things, waiting in the dark. It humbles us, reminds us that we are small in a grand, ancient ballet of gravity and chance. And yet, that's not a reason to fear. It's a reason to appreciate, to look up at the night sky and marvel that we are here on this tiny blue world, spinning safely around a warm, steady star. It's a miracle of odds, a beautiful fluke of physics. As you settle into sleep, let the vastness comfort you. The rogue planet, if it exists, is still unimaginably far away, and Earth for now remains cradled in calm orbits. The stars whisper stories of danger, yes, but also of survival. We are here, and that is enough. Let that thought drift through your mind like a quiet planet through the deep. You are safe. You are home. 7. Change in the cosmological constant. Tonight, let us leave the stars and the planets behind for a moment and turn our gaze inward to the quiet, invisible framework of reality itself. You may have heard of the vacuum of space, that vast emptiness between galaxies where nothing seems to reside. But in truth, the vacuum is not nothing. It hums with invisible energy. Tiny particles flicker in and out of existence, governed by the quantum rules that underlie all things. And that invisible foundation, that baseline of energy, is called the vacuum state. Now here's where it becomes truly strange. What if this vacuum isn't the most stable it could be? What if the universe is only balanced precariously on a false floor? A state that feels solid, but isn't truly permanent. This is the unsettling idea behind a concept known as vacuum decay. According to some interpretations of quantum field theory, our universe may be sitting in a false vacuum. It behaves like the lowest energy state, but it isn't. Somewhere out there, perhaps far beyond what we can see, the true vacuum might already exist. And if that's the case, then one day, perhaps tomorrow, perhaps in 1 trillion years, a tiny bubble of true vacuum might form and begin to expand. Not slowly, not with a warning, but at the speed of light. This bubble wouldn't burn or explode in a way we could see. There would be no time to react, no sirens, no countdown. The instant it touched our solar system, the very laws of physics would change. The fundamental forces, gravity, electromagnetism, the strong and weak nuclear forces, might no longer behave the same. Atoms could dissolve. Matter as we know it might simply stop existing. And because this expansion happens at light speed, we'd never see it coming. One moment, everything would be as it is, and the next moment, it would all be gone. It sounds terrifying, but it's not all doom and gloom. This idea isn't just theoretical horror. It's also a humbling reminder of how incomplete our understanding of the universe remains. The possibility of vacuum decay is rooted in the discovery of the Higgs boson, the elusive particle found in 2012. Calculations based on the Higgs field suggest that, given certain conditions, our universe may indeed be in a metastable state. But, and this is important, the chance of vacuum decay happening anytime soon is astronomically small. The universe has existed for nearly 14 billion years without incident. And even if the vacuum were to decay far from us, in a distant galaxy, its bubble would need billions of years to reach us. So what does this mean for you, lying here beneath a blanket of stars? It means that even the most profound cosmic threat isn't something to fear in this moment. Instead, it's a reminder of how finely tuned the universe truly is, that we exist at all, on a planet with air to breathe, sunlight to warm us, and minds that can ponder these mysteries, is something extraordinary. Vacuum decay, for all its drama, is quiet, invisible, and still only a possibility among many. It humbles physicists, but it doesn't haunt them. They sleep well at night, and so should you. So rest now, knowing that for all its complexity, the universe is holding steady. The stars still shine, the constants still hold, the vacuum has not collapsed, the bubble has not formed, and all is calm. Let go of the noise and let the stillness of the cosmos cradle your thoughts. You are safe in this fleeting and beautiful moment of cosmic peace. 8. Milky Way Andromeda collision. Let your mind drift far beyond Earth now, beyond the sun, beyond even the edge of our solar system. Tonight, we're sailing into the distant future, billions of years from now, when the universe itself will stage one of the grandest events in cosmic history. The Milky Way galaxy, our galactic home, is not standing still. It's slowly moving through space, an immense disk of stars, dust, gas, and dark matter, all rotating around a central supermassive black hole. And heading toward us, across 2.5 million light-years of empty space, is another galaxy, Andromeda. Andromeda is larger than the Milky Way and just as magnificent. It too spins silently through the universe, pulled by gravity. For billions of years, these two spiral giants have been on a slow, inevitable collision course. In about 4 to 5 billion years, they will meet. Now, when we think of a collision, we might imagine chaos, explosions, crashes, destruction. But galaxies are mostly empty space. The stars are separated by light years. So when galaxies merge, stars usually pass right by one another. The real transformation happens not from physical crashes, but from gravity. As the Milky Way and Andromeda approach, their shapes will distort. Tidal forces will stretch the spirals into long, flowing streams of stars. Clouds of gas will crash together, sparking waves of new star formation. Some ancient stars may be ejected into intergalactic space. Others will find themselves in entirely new orbits. Earth, if it still exists, will witness a dramatic shift in the night sky. First, Andromeda will appear as a growing blur, then a grand arc, and finally as a swirling storm of stars overhead. For thousands of years, our sky will dance with a cosmic fireworks show, an awe-inspiring ballet of light and motion. At the centers of both galaxies lie supermassive black holes. When they meet, they may spiral around each other in a gravitational waltz, eventually merging into one colossal black hole. This event would ripple through space, sending gravitational waves, subtle vibrations in the fabric of reality across the universe. The final result? A single, larger galaxy, likely elliptical in shape. Astronomers call it Milky, a smooth, rounded halo of stars, a quiet resting place for two once spiraling giants. But what happens to Earth? That part is uncertain. We may be gently swept into a new orbit within Milky. Or, like a leaf in a storm, Earth could be cast adrift, thrown out into deep space, alone and cold. But by the time this collision happens, our sun will already be near the end of its life. It will swell into a red giant and likely render Earth uninhabitable long before the galaxies meet. So this collision, while grand, is not a threat to us. It is instead a reminder of the universe's slow and majestic movements, that nothing is fixed, even galaxies drift, even giants fall into each other's arms. Tonight, as you drift into sleep, imagine that quiet dance, two galaxies swirling closer across billions of years, not with violence, but with grace, with beauty. The stars will not scream or roar, they will shine quietly as they always have, and so will you. Breathe deeply. The cosmos is calm. Let yourself drift like a star in the stream of the Milky Way, cradled by the soft pull of gravity and time. You are part of this dance too. Sleep well. 9. The sun's red giant phase. In the quiet stillness of the night sky, we see the sun as a perfect point of light, steady, constant, and unchanging. It gives us warmth and life, guiding our days and nights, an eternal presence that anchors us to the rhythm of time. But though the sun feels eternal, it is not. Like all stars, it has a lifespan, and one day it will reach the end of its journey. The sun, as we know it, is in the middle of its life. It has been burning for about 4.6 billion years, converting hydrogen into helium through nuclear fusion in its core. This process has sustained the sun and allowed it to shine, radiating energy out into the vast expanse of space. But nothing lasts forever. The sun's hydrogen supply is running out, and when that fuel is gone, a transformation will begin, one that will change the sun and the earth forever. In approximately 5 billion years, the sun will exhaust the hydrogen in its core. As this happens, the core will contract under gravity and the outer layers will expand. The sun will become a red giant, a swollen, fiery star that will engulf the inner planets of the solar system. Mercury and Venus will be swallowed whole, their surfaces scorched by the intense heat. And what of Earth? The Earth will not be immediately consumed. In the initial stages of the red giant phase, the sun's increased luminosity will raise temperatures on Earth. The oceans will boil away, and the atmosphere will escape into space, leaving the planet barren and lifeless. Life, as we know it, will cease to exist long before the sun's outer layers actually touch the Earth. But this process will not be sudden. For billions of years, the sun will gradually increase in size, shedding layers of its outer atmosphere. As the sun grows, its mass will decrease, weakening its gravitational pull. This could cause Earth to drift away from its current orbit, possibly saving it from direct destruction by the expanding sun. Yet, even if Earth escapes the sun's physical reach, it will be unable to support life in its transformed state. The oceans, The atmosphere, the surface, everything will slowly be incinerated as the sun's heat intensifies. As the sun's core continues to collapse, it will reach a point where helium fusion begins, igniting a new stage of life for the star. The sun will go through cycles of expansion and contraction, throwing off material in massive solar winds. These solar winds will strip away any remaining vestiges of Earth's atmosphere, and the planet will become a cold, dry rock, orbiting the remnants of its former life-giving star. But the story does not end there. After the sun sheds its outer layers, it will become a white dwarf, a dense, glowing ember, still emitting faint heat. This white dwarf will slowly cool over the course of trillions of years, becoming a cold, dark cinder in the void of space. For humanity and for all life on Earth, the death of the sun is far in the future. It is an event so distant that it is almost impossible to truly comprehend. But as we look up at the sun today, we are reminded of its fragile existence. The light we see shining down on us is the product of a star that is halfway through its life cycle. The energy we receive is finite. It is a gift that has allowed life to flourish on this planet, and yet it is not an eternal gift. The sun will one day die, and with it, the Earth will feel the warmth of its final stages. The death of the sun is not an event to fear. In fact, it is a part of the natural life cycle of all stars. The process that will transform the sun into a red giant and eventually a white dwarf is the same cycle that has played out in countless stars across the cosmos. Stars are born, live, and die. It is their deaths that create the elements necessary for the formation of new planets, new stars, and even new life. The sun's death will be the final act in a long story of cosmic evolution, one that has been unfolding for billions of years. As you contemplate this grand cosmic process, remember that our sun is just one of countless stars. It is a star of middle age, an ordinary star in a universe filled with extraordinary events. It is part of a never-ending cycle of creation and destruction, a reminder that everything in the universe is in motion. The sun will one day die, but it will do so in a way that paves the way for new stars, new worlds, and new possibilities. Its death is not an end, but a transition. It is the inevitable closing of one chapter and the opening of another. As you gaze upon the stars, remember that the sun's journey is shared by countless others. Every star is born, lives, and eventually dies, shaping the cosmos in its wake. It is a cycle of creation and destruction, one that will continue long after our time. And even in the face of such an inevitable end, the universe persists, ever changing, ever evolving. And we, as part of this grand cosmic dance, are part of something much larger than ourselves. 10. Reversal or collapse of Earth's magnetic field. We often think of Earth as a stable, unchanging environment, an oasis of life amid the endless expanse of space. It is easy to take for granted the steady pull of gravity, the constant rotation, the gentle warmth of the sun. But Earth's stability is not as assured as it seems. Beneath the surface, a complex system of forces keeps our planet intact and habitable. And one of the most crucial, yet often overlooked, elements of this system is Earth's magnetic field. Earth's magnetic field is generated by the movement of molten iron and other metals within the outer core. This magnetic field acts as a shield, protecting life on Earth from harmful solar radiation and cosmic rays. Without it, the sun's energetic particles would strip away our atmosphere, making life impossible. It is this magnetic shield that gives us the atmosphere we depend on, that keeps our weather patterns stable, and that even helps animals navigate across the planet. But what if that shield were to weaken or collapse? Over the course of Earth's history, the magnetic field has flipped multiple times. The north and south magnetic poles have swapped places, with the poles moving slowly but steadily over time. These reversals are natural, though they are unpredictable in their timing. The most recent reversal, known as the Matuyama-Brunhes reversal, occurred approximately 780,000 years ago. Since then, Earth's magnetic field has remained relatively stable, but scientists know that another reversal is bound to happen at some point. A magnetic reversal is not an event that would immediately wipe out life on Earth. The process would unfold over thousands of years, and Earth's atmosphere would still provide some protection against solar radiation. However, the weakening of the magnetic field during a reversal could expose the planet to increased radiation from the sun, which could have serious consequences for both life and technology. Increased radiation would mean more damage to satellites, communication systems, and electrical grid infrastructure. But even more dangerous than a reversal is the possibility that Earth's magnetic field could collapse entirely. If the magnetic field were to completely disappear, the planet would lose its protective shield, leaving it vulnerable to the full force of solar radiation. The sun's charged particles could strip away the atmosphere, leaving Earth exposed to the harsh conditions of space. Without the magnetic field, Earth would be like a barren, lifeless rock, much like Mars, which has no significant magnetic field of its own. The collapse of Earth's magnetic field is considered highly unlikely in the short term. However, the possibility cannot be entirely ruled out, and scientists are working to understand the behavior of Earth's core and magnetic field more deeply. If such a collapse were to happen, it would be a gradual process, one that would unfold over thousands or even millions of years. But the consequences would be devastating for life on Earth, as we would lose the very thing that protects us from the ravages of space. In the vast timeline of the universe, Earth's magnetic field is a relatively recent feature. It has protected life for billions of years, and it will continue to do so for a long time yet. But like all things in the universe, it is not permanent. It is just one more reminder of the delicate balance that allows life to exist on our planet. And it is a reminder of how fragile and interconnected our world is, how reliant we are on forces beyond our control, and how everything, even the magnetic field that keeps us safe, is in a constant state of change. But for now, Earth's magnetic field continues to protect us, keeping our skies shielded and our world stable. It will continue to do so for the foreseeable future, allowing us to live, grow, and thrive. And while we may not know what the future holds, we can rest in the knowledge that we are part of a cosmic system that has nurtured life on this planet for billions of years, and will continue to do so for a long time yet. 11. Galactic core jet or explosion. Far from the peaceful twinkling stars that paint the night sky, at the heart of every large galaxy, something far more enigmatic and powerful resides. At the center of the Milky Way, like many galaxies, there exists a supermassive black hole. It is a force of unimaginable gravity, holding the galaxy together while consuming everything in its vicinity. But this black hole isn't just a quiet, invisible object in the distance. No, it has the potential to become an active and violent source of cosmic destruction. The presence of a supermassive black hole in the center of galaxies is well established. However, many of these black holes, including Sagittarius A star, remain dormant, quietly consuming matter from the galaxy's surroundings. But sometimes these black holes can ignite, triggering spectacular events. This can happen when large amounts of gas and dust fall into the black hole, causing a dramatic release of energy. This process is known as accretion, and it can lead to the formation of powerful jets of material that shoot out from the black hole's poles. When such jets are ejected, they release incredible amounts of energy, far more than the total energy output of an entire galaxy. This immense radiation can strip away the gas and dust surrounding the black hole, preventing the galaxy from forming new stars and potentially halting the growth of the entire galactic system. If the black hole at the center of the Milky Way were to suddenly activate and release such jets, the effects could reach far beyond the galactic core, impacting the solar system in unforeseen ways. For Earth, the consequences of an active black hole in the Milky Way center could be disastrous, though the chances of this happening anytime soon are very low. If Sagittarius A star were to release a massive jet of radiation in our direction, it would likely strip away Earth's ozone layer, exposing the planet to harmful ultraviolet radiation from the sun. Over time, this radiation could potentially destroy much of the atmosphere and make the Earth inhospitable to life. Thankfully, astronomers believe that Sagittarius A is not on the brink of an outburst. It has remained relatively quiet for billions of years, and current evidence suggests that it's unlikely to start ejecting massive jets anytime soon. However, the possibility remains that this calm may not last forever. If the accretion of matter accelerates at the center of the Milky Way, the black hole could eventually become active, unleashing a burst of energy that could reshape the galaxy and even threaten the future of our solar system. A more extreme scenario involves an explosive event at the galactic core. If the conditions were right, Sagittarius A star could theoretically go into a hyperactive state, emitting an intense burst of radiation and particles. This would not only disrupt the Milky Way, but could also send destructive waves of cosmic rays across the solar system. Such an explosion would be catastrophic, especially for life on Earth. But again, these events are exceedingly rare and would unfold on timescales far beyond human comprehension. In the grand scheme of things, such an event is unlikely to happen anytime soon. The black hole at the center of the Milky Way is currently in a dormant state, and we are safely positioned at a distance far from the galactic core. But just knowing that this cosmic force exists, capable of changing the fate of an entire galaxy, serves as a powerful reminder of the forces at play in the universe. It's a humbling thought, one that draws attention to our place within the vastness of space. Earth, though tiny, remains safe for now. This knowledge, unsettling as it may seem, doesn't diminish the beauty of the universe. Instead, it emphasizes the sheer scale of time, the vastness of space, and the unpredictability of what lies ahead. The stars we see in the sky shining with a soft glow may one day experience their own version of death, but for now, we remain in a moment of cosmic serenity. The universe continues to move, to spin, to breathe, but for now, it does so without alarming us. 12. Nearby star system instability. For much of human history, the stars have been our navigational guides, our sources of inspiration, and our markers of time. The constellations have told stories, guided sailors across oceans, and been the backdrop for countless human endeavors. But beyond their beauty, the stars also harbor hidden dangers, some of which could bring sudden catastrophic changes to our solar system. Imagine, for instance, that a nearby star system undergoes instability, perhaps a supernova or a dramatic change in the behavior of one of its stars. One of the nearest star systems to us is Alpha Centauri, a 3-star system located just over 4 light-years from Earth. It consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and the much smaller Proxima Centauri, which is the closest of the 3 to Earth. Although these stars are relatively stable now, their proximity to our solar system means that any instability in this system could have significant consequences for Earth. If one of the stars in the Alpha Centauri system were to undergo a catastrophic event, such as a nova or even a supernova, the effects could ripple through space, potentially reaching our solar system. A supernova, which is the explosion of a dying star, releases an enormous amount of energy in the form of radiation. This radiation can travel vast distances, and if the explosion were to occur near enough to Earth, it could cause significant damage. The radiation from a nearby supernova could strip away Earth's atmosphere, leaving the planet exposed to the harsh vacuum of space. Without an atmosphere, Earth would lose its protective shield against cosmic radiation and solar particles, making it inhospitable to life. While the likelihood of a supernova in Alpha Centauri is low, the possibility that a nearby star could undergo such an event is always present. Even more worrying is the potential for a gamma ray burst, a highly energetic explosion that could easily devastate Earth if directed our way. In addition to these extreme scenarios, Alpha Centauri and other nearby star systems may also experience stellar flares. These flares, violent eruptions of energy from the star's surface, can release vast amounts of radiation. While most stellar flares in Alpha Centauri are not strong enough to harm Earth, an unusually powerful flare could disrupt Earth's magnetosphere, damaging satellites, communication systems, and power grids. These types of stellar eruptions are a natural part of a star's life cycle, but an event of sufficient magnitude could have wide-reaching consequences. Fortunately, Alpha Centauri is relatively quiet at the moment. Proxima Centauri, the closest star, has exhibited flare activity in the past, but none of these events have been close enough to cause harm to Earth. Similarly, Alpha Centauri A and B are both stable stars, and the likelihood of a catastrophic event in this system is relatively low. Still, the fact that we live in a galaxy full of dynamic and active stars means that the possibility of sudden cosmic events is never entirely absent. The dynamic nature of the universe means that we are always at the mercy of forces beyond our control. Stars are born, live, and die, and when they do, they shape the very fabric of the space around them. Earth, while nestled in the quiet arms of the sun, is still part of a much larger cosmic system, one that is constantly in motion. The instability of nearby stars, though rare, serves as a reminder of how fragile our existence is within this ever-changing universe. However, the chances of Earth being directly affected by an event in the Alpha Centauri system are extremely low. While these events are part of the natural evolution of stars, they do not typically threaten life on Earth. The stars in Alpha Centauri are far enough away, and their instability, though fascinating, does not directly endanger our planet. And yet, even as we rest on this fragile world, we are connected to a vast universe filled with stars, some of which may one day undergo catastrophic events, shaping the future of the cosmos. 13. Loss of the Moon. The Earth and the Moon share a profound and ancient relationship. They have existed together for over 4 billion years, locked in a delicate cosmic dance. The Moon, with its gentle pull, stabilizes the Earth's axial tilt, giving us predictable seasons and a relatively stable climate. Without the Moon, Earth's tilt could shift dramatically, leading to catastrophic changes in the climate. But what if the Moon were to disappear? What if one day it simply vanished from our night sky? The Moon's role in stabilizing the Earth's axial tilt is crucial. Our planet is tilted at an angle of about 23.5 degrees relative to its orbit around the Sun. This tilt is what gives us the changing seasons, the steady rhythms of spring, summer, fall, and winter. If the Moon were to be removed, Earth's axial tilt could fluctuate wildly over long periods, causing extreme and unpredictable shifts in climate. The seasons could become erratic, with some regions experiencing extreme temperatures and others facing extreme cold or heat. While the Moon's loss might seem like an apocalyptic event, it is important to understand that this would not happen suddenly. The Moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. Over billions of years, this slow drift would eventually cause the Earth to lose its satellite, but this process is so gradual that it would not affect life on Earth in the near future. However, if something were to accelerate the Moon's departure, such as an asteroid impact or a gravitational disturbance in the solar system, it could drastically alter the balance. Without the stabilizing influence of the Moon, Earth's climate could become chaotic. Over the course of millions of years, the planet's axial tilt could shift dramatically, leading to severe fluctuations in temperature and seasons. In some scenarios, the Earth could become locked in a permanent ice age, or conversely, experience periods of intense heat. The ecosystems that depend on the predictable seasons could be thrown into disarray, causing mass extinctions and irreversible changes to the planet's surface and environment. But beyond the climatic shifts, the loss of the moon would also have profound effects on the tides. The moon's gravitational pull creates the tides, which are essential for maintaining the health of coastal ecosystems. Without the moon, these tidal forces would cease to exist, and the oceans would become far less dynamic. This would affect marine life, particularly those species that rely on tidal rhythms for breeding, feeding, and migration. The loss of the moon would not only change the Earth's climate and ecosystems, but would also disrupt the delicate balance that supports life on this planet. Despite the potential upheaval caused by the moon's disappearance, it is worth remembering that this is a distant and highly improbable event. The moon is not likely to vanish anytime soon. Instead, we should appreciate the unique and delicate relationship we share with this celestial body. The moon has been a constant presence in our sky, guiding us through the ages, marking time and offering inspiration. It is a symbol of the steady, predictable nature of the universe, a reminder that even in the vastness of space, some things remain constant. The moon, like the stars, is a fixture in our existence. While its eventual loss may be inevitable, it will not happen within our lifetimes. And for the time being, we can continue to marvel at its beauty and significance. The moon will continue to rise each night, its soft glow a gentle reminder of the cosmic forces that shape our world. As you look up at the moon tonight, let it serve as a reminder of the delicate balance that makes life on Earth possible. It is not just a satellite, but a partner in our journey through space, guiding us through the cycles of time and providing stability in the ever-changing cosmos. The moon's presence is an ancient connection to the rhythm of the universe, a reminder of our place in the grand tapestry of existence, and a symbol of both the fragility and resilience of life itself. 14. Planetary axis flip. The Earth is a dynamic planet, constantly shifting and changing. From its surface to its core, the forces that shape our world are in a constant state of flux. One of the most profound, yet largely unnoticed, changes that occurs over long periods of time is the shifting of Earth's axis, an event known as true polar wander. While we are familiar with the concept of the Earth's rotation and its axial tilt, the idea that the planet's axis could actually shift is both fascinating and unsettling. True polar wander refers to the movement of the entire planet's rotation axis relative to its surface. While Earth's axis is currently tilted at about 23.5 degrees, this tilt is not fixed. Over the course of millions of years, the Earth's axis has shifted slightly, causing the poles to wander. This phenomenon occurs due to the redistribution of mass within the planet, such as the movement of tectonic plates or the melting of ice sheets. These changes can cause the planet's center of mass to shift, which in turn can alter the orientation of the entire planet. While true polar wander is a natural process that occurs over long timescales, it can have dramatic effects on the planet's surface. The most immediate consequence of a large-scale shift in the Earth's axis is the realignment of the continents and oceans. This could cause massive earthquakes, volcanic eruptions, and the reshaping of the Earth's surface. The effects of true polar wander are not just theoretical, they have happened in Earth's history. Fossil evidence suggests that during previous episodes of true polar wander, the planet's surface underwent profound transformations. The consequences of true polar wander go beyond just geological changes. The redistribution of mass that causes the planet's axis to shift could also have dramatic effects on the Earth's climate. As the axis moves, the regions of the Earth that experience different amounts of sunlight will change. This could cause extreme climate shifts, with some regions becoming much hotter and others experiencing prolonged periods of cold. These changes could have catastrophic effects on ecosystems, agriculture, and the habitability of different regions of the Earth. The realignment of the Earth's axis would also cause a dramatic change in the positioning of the poles. If the North and South poles were to shift, it could have profound effects on the planet's magnetic field. The Earth's magnetic field is generated by the movement of molten iron in the outer core, and this magnetic field is crucial for life on Earth. It shields the planet from harmful solar radiation and helps maintain a stable climate. If the poles were to shift drastically, it could affect the magnetic field, making Earth more vulnerable to solar winds and cosmic radiation. True polar wander is a gradual process that occurs over millions of years, so it is unlikely to happen abruptly or cause sudden catastrophic events. However, the potential consequences of this shift are significant, and scientists continue to study the forces that drive true polar wander. While the Earth's axis is unlikely to shift dramatically in the near future, it serves as a reminder that the planet is not a static, unchanging place. It is a world in constant motion, shaped by the forces of gravity, tectonic activity, and the movement of mass within the Earth itself. Despite the potential for disruption, true polar wander is not something to fear. It is a natural process that has shaped the Earth throughout its history. It is part of the planet's ongoing evolution, and while the consequences of such a shift may be profound, they are not cause for immediate concern. Earth has weathered many changes over the billions of years of its existence, and it will continue to do so. As you think about the forces that shape our planet, remember that Earth is not just a place we live. It is a living, breathing entity in its own right. The forces that drive its movement, its rotation, and its tilt are part of what makes our world so dynamic and unique. And as we continue to live and evolve on this planet, we are forever linked to the ever-changing dance of the Earth's motion. 15. Heat death of the universe. The stars that light up the night sky, the galaxies that stretch out beyond our comprehension, the planets that orbit distant suns, these are all part of a vast and ever-changing universe. But as we look to the stars, we also must confront the inevitable fate that awaits everything in the cosmos: the heat death of the universe. The concept of heat death is rooted in the laws of thermodynamics, the fundamental principles that govern energy, heat, and work. According to the second law of thermodynamics, the total entropy or disorder of a closed system will always increase over time. In simple terms, energy will naturally disperse, spreading out and becoming more evenly distributed. This process leads to a state where no more work can be done and everything reaches a uniform temperature. This state of maximum entropy is what science has dubbed the heat death of the universe. At present, the universe is filled with stars, galaxies, and nebula, vast structures that emit energy in the form of light and heat. But these stars are not eternal. Over time, they burn through their nuclear fuel, eventually exhausting their energy and entering the final stages of their life cycle. Some stars will become white dwarfs, others will explode as supernovae, and the most massive will collapse into black holes. As stars die and the energy they emit diminishes, the universe will gradually become colder and darker. Eventually, all the stars will burn out. The remaining remnants of stellar cores, white dwarfs, and black holes will drift in the vast emptiness of space. There will be no more new stars forming, no more bursts of energy lighting up the cosmos. As the universe continues to expand, it will grow colder and colder, with all matter and energy becoming increasingly diffuse. Galaxies will drift apart, the fabric of space-time stretching ever farther. One of the key events in the heat death scenario is the eventual evaporation of black holes. While black holes are known for their immense gravitational pull, they are not invincible. Over incredibly long timescales, black holes will slowly lose mass through a process called Hawking radiation, proposed by physicist Stephen Hawking. This radiation occurs because, at the event horizon of a black hole, quantum effects cause the creation of particle-antiparticle pairs. Some of these pairs escape as radiation, carrying away a small amount of energy, ultimately leading to the gradual loss of mass in the black hole. Over trillions of years, this process will cause the black hole to lose its energy and evaporate, leaving behind only a faint trace of what once existed. As the universe continues its slow march toward equilibrium, everything will reach a uniform temperature, a state known as thermal equilibrium. At this point, all matter will be spread out across an infinite and cold universe, and no more energy will be available to do any work. Stars will have ceased to shine, black holes will have evaporated, and even the most fundamental particles will have decayed into a uniform state. There will be no light, no movement, and no change, just a vast, empty, dark universe where nothing occurs. This state of heat death represents the ultimate end of the universe, a fate that is inevitable according to our current understanding of physics. It will take an unfathomable amount of time, trillions of years, if not longer, before the universe reaches this final, still state. But it is the natural conclusion of the laws of thermodynamics. The universe, once full of energy and activity, will eventually settle into a state of perfect balance, where nothing can change and everything is as cold and still as the emptiness of deep space. As we contemplate the heat death of the universe, it serves as a reminder of the fleeting nature of existence. The stars that shine brightly above us today will one day burn out, and all the galaxies we can see with our most powerful telescopes will eventually fade into the darkness. The very fabric of the universe, as vast and enduring as it seems, is in a constant state of change, moving toward a distant and cold conclusion. And yet, despite this inevitable end, there is something beautiful in the way that everything has a cycle. The heat death of the universe is not a cause for despair, but rather a reflection of the incredible journey the cosmos has already taken. From the Big Bang, when all the energy and matter of the universe was concentrated into a singularity, to the vast expanding universe we see today, the cosmos has been in a constant state of flux. It is this constant change, the cycle of creation and destruction, that makes the universe so captivating. Even in the face of ultimate entropy, there is a beauty in the understanding that all things, even the universe itself, are part of an eternal cycle. The beginning and the end are intertwined, and the transformation is what gives meaning to everything we experience. For now, we exist in a universe that is still full of energy, still capable of change, and still home to countless stars, planets, and galaxies. But one day, far in the future, all of this will come to an end. The stars will die, the galaxies will drift apart, and the universe will settle into a cold, quiet state of maximum entropy. But that day is so far in the future that it is impossible to comprehend. For now, we can marvel at the beauty and complexity of the universe and appreciate the time we have here. The heat death of the universe may be an inevitable fate, but it is also a part of the natural cycle of the cosmos. The universe was born in an explosion of energy, and it will eventually reach a state of rest. It is a reminder that everything in the universe is in motion, constantly evolving and changing. And while we may not be here when the universe reaches its final still state, we are part of this incredible journey, one that spans across the vast stretches of time and space. The stars are still whispering, but your eyes are growing heavy. Though the universe holds strange and shadowy facts, they lose their edge when wrapped in stillness. If you're still awake, feel free to stay and drift through more celestial calm. And if you've already drifted off, Sweet dreams among the stars. Good night, traveler of the galaxy.